Now, this is the final part of this particular review where we'll be looking at the applications of all what we've learned, coming from light to optics to lenses and mirrors. And here we're going to look at number 11, which says that we should describe two uses of converging mirrors and divergent mirrors. Now, if you look at this first part right here, you see a converging mirror where the center curvature is actually away from the focus, and also looking at the slash lines right there, this actually tells us in a way that one, we have a converging or concave mirror. Another way of looking at it is by looking at this circle right here. On one side, when ray of light is actually coming towards this particular, I would say, circle, we notice that on one side here, where the slash lines are all pointing to the right of this particular screen, we see that the smooth surface shows here that there is a divergent aspect that is related to the rays, while on the other side there is a convergent effect. So the convergent effect is related to the concave mirror. However, on the other side, the divergent effect is actually linked to convex mirror. So for converging mirrors, it's usually used in shaving mirrors to see clearly, and also a Hubble telescope, which is what you see right here. You see an object, a person actually standing in front of this particular concave mirror, and this shows that, hey, one, the person is actually upright, two, the image is actually virtual, it's not real, and three, finally, is that, well, the object is actually larger than you think. So that's about it for the converging mirror. And the next one here is divergent, which is convex mirror. Example includes car side mirrors and also security cameras. And that's about it for 11. Number 12 in here asks the question, why do diamonds, why do they sparkle, and why? So the main reason is just the concept of the total internal reflection, which we talked about on our, I would say, previous lesson. And this is when light incident rays from air refraction into diamond causes the new medium, which is diamond, to not allow the light rays to not come out easily. The light rays remain trapped inside the diamond medium, thereby causing this particular couple of internal reflections, one here and one there, and then finally later on comes out. All this is due to the little internal dimensions that diamond has, that the plane mirrors in it causes couple of reflection and reflection inside internally, that results in all this sparkling effect happening right here in diamonds, which is pretty cool. Now number 13 here talks about a converging lens, and in here we're going to see an object which is between the focus here and the, I would say, center of this particular converging lens, and we're asked to actually describe or draw the ray diagram that results in the image you see. So in this particular part, what we do notice is that our rays is going to come from P, and is going to have to write this P properly here. We have the P, which is our object, and we have our rays coming from P to the center line right here of this particular lens, and then it converges downward all the way this way. Now on this other side, if we start at this point again and we approach the center circle right there of this particular mirror and goes downward, these lines, they don't actually meet in a way. However, if you create a projection from this particular reflection right here over to this other side, and this point right there over to this other point, we should be able to actually get our image of our particular object. So while this is our image of our object, we can conclude that, hey, our image is actually larger, upright, but it is a virtual image than our object, or compared to our object. So that is about it for this particular part. An example of a convergent lens is magnifying lenses and also your eye lens. Now number 14 in here talks about when shining white light or ray beams at one side of a triangular prism, what do you notice at the other side of the prism? So in here we have an illustration right here, and what we notice is that this triangular prism causes this medium to create this spectrum of lights, and this visible spectrum of light is similar to what we know in rainbow, and this is actually due to the concept which is called the law of refraction, where once light travels from one medium to another medium, light actually bends in that particular case, which results in the formation of that visible spectrum right there. So red light bends less than violet light, which is what we have right here, versus that one what we have right there. So in this case we can actually apply this a little bit to the second prism, where if you add that into this particular space, we create our white light back, and this actually shows the concept of color addition. And this experiment was actually performed by Isaac Newton, so it's quite incredible to see how you're able to apply what you know to Isaac Newton's concept of light and also the visible light spectrum. So that's about it for this particular question. And the final one is, what happens when light rays at the end of each set of mirror or lens setup, and you should actually follow the light ray in alphabetical order, and which detector will the light ray actually hit at the end of this particular journey. So first we need to take note a little bit of this particular concept here, which is our normal line that is perpendicular to our mirrors right here. So once we have our light rays coming in, they actually bounce from one side to another side, and take note here that the angles here are equal, the angle incidence and the angle of reflection equal over there. And this other one here, we can do the same thing, bounces and then approaches this region and then continues right there. And so as you're going through the journey, it approaches the divergent lens, and what divergent lenses does is that it spreads out our rays all the way outward, and then this approaches a converging lens. And what converging lenses do is that it brings the rays back together, and what happens is that our rays finally they hit detector 2. So that's about it for this particular application of combining rays and lenses and also mirrors to see or direct light from one particular location to another location. Thanks for following me through this. Stay smart, all the best, and believe in yourself.